4.5 billion years ago, the Earth was a violent and chaotic place. During this time, a Mars-sized planet called Theia collided with our young planet. The massive impact partially ripped Earth apart and shattered Theia, fusing the planets together. This event ejected so much rock into orbit that it eventually formed the Moon. Scientists agree that life couldn't have survived such a collision. However, life emerged about 500 million years later, which is incredible, given that Earth was bombarded by large asteroids for hundreds of millions of years. These asteroids, some over 1,300 kilometers in diameter, struck Earth with such force that they melted parts of the crust and vaporized oceans. It's hard to imagine how life could have started while Earth was repeatedly hit by planet-sized impacts. Additionally, the early Earth was inorganic, lacking the fundamental molecules needed for life. So, how did the chemical ingredients for life form? Asteroid impacts, which made Earth seem uninhabitable, might have played a role in cooking the planet's primordial soup. Before life in the form of creatures, algae, or cells emerged, chemical reactions likely took place, replicating molecules and passing on information, the precursor to genes. RNA, peptides, and proteins were likely early players in these reactions. Nucleobases, organic molecules forming the ingredients for RNA, were crucial. Many scientists believe RNA was the first self-replicating molecule, leading to life. Amino acids, which build proteins and peptides, are also essential for life's reactions. But Earth didn't start with these pieces. Today, life's building blocks mostly come from other life. The first versions of these molecules had to form without life. So, how did it start? In 1952, Stanley Miller, a PhD student at the University of Chicago, had an idea. He believed that by recreating early Earth conditions in a lab, we could form the ingredients for life. Miller set up an experiment with water and gases like methane, ammonia, and hydrogen, representing what the early atmosphere might have been like. He added heat and electrical sparks to simulate lightning. After a week, the mixture turned reddish-brown, and 5 amino acids were produced. Miller's experiment showed that lightning could organize inorganic substances into proteins building blocks. However, Miller's model of the early atmosphere was likely incorrect. We now know that the Hadean atmosphere was mostly carbon dioxide and nitrogen, which is weakly reducing. This change in understanding means that Miller's experiment doesn't work as well in a weakly reducing atmosphere. Additionally, in this atmosphere, lightning would have been less common, requiring stronger electric fields. Interestingly, Harold Urey, a chemistry professor and co-conspirator of Miller, had proposed that asteroid impacts could have temporarily altered the chemistry of the atmosphere. However, their famous experiment didn't simulate asteroid impacts. A 2023 study modeled how asteroid impacts changed early Earth's chemistry. For example, a large iron asteroid collided with Earth, vaporizing oceans and melting the crust. The impact scattered iron throughout the atmosphere, creating hydrogen gas. Over time, this hydrogen reacted with nitrogen and carbon dioxide, forming methane and ammonia. This created a reducing atmosphere, enabling lightning to form amino acids,